Hello everyone. This question requires us to prove by mathematical induction that the sum of natural numbers is always equal to n, open up the brackets, n plus 1, close the brackets, everything divided by a 2. Now to do this, we are going to go through 3 steps, okay? Now step number 1, we are going to prove that this formula is valid for n is equal to a 1, okay? So we are going to substitute this n is equal to 1 on the left hand side and on the right hand side of this equation, okay? So we are going to have left hand side. This will give us, where is n, we substitute a 1, okay? And this will give us a 1. Now on the right hand side, remember our formula is n into n plus a 1 divided by a 2. So we are going to substitute a 1 into our formula, okay? And when we do that, we shall have a 1 into 1 plus a 1, everything divided by a 2. 1 plus 1, we get a 2. So this will give us 1 times a 2, everything divided by a 2. So this 2 will cancel with this 2, and our right hand side of the equation will be equal to 1. And when we look closely, left hand side is equal to right hand side. And since this is true, so we shall say that the formula is valid for n is equal to a 1. Step number 2, we are going to assume that this formula is valid for n is equal to a k. So we say, step 2, assume the formula is valid for n is equal to a k. So we get k, we substitute where there is n. So we shall have 1 plus 2 plus 3 plus dot 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 plus a k, and this is equal to a k into k plus 1, everything divided by a 2. Now after doing that, we are going to go step number 3. And on step number 3, we are going to prove that if, yes, this formula is valid for n is equal to k, comma, it must hold for n is equal to k plus a 1, right? So we are going to get this n is equal to k plus 1. We substitute on the right hand side and on the left hand side. So don't forget that we stopped at n is equal to k. So we shall have 1 plus a 2 plus a 3 plus dot 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 plus k. But now we added a 1 onto a k. This means that we moved one step forward. So we shall have a k plus 1, everything is equal to, where there is n, we substitute a k plus a 1. So this is equal to k plus 1, open brackets, Now, this is k plus 1. We are going to add a 1 onto a 1. This will give us a k plus 2, everything divided by a 2. Now, when we look at step number 2, 1 plus 2 plus 3 plus dot 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 plus a k, this gives us k open brackets, k plus 1 close brackets, everything divided by 2. And we are seeing it on step number 3. What does that mean? Instead of writing 1 plus 2 plus 3 plus dot 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 plus k, yes, I'm going to instead write k into k plus 1 divided by a 2, then plus k plus 1, everything must be equal to k plus 1 into k plus 2, everything divided by a 2. After doing that, I'm going to make sure that this guy has the same denominator with this guy. How am I going to do it? I first multiply with a 2, then I divide with a 2. Okay? And after doing that, our left hand side will be equal to, the common denominator is 2. Okay? So here we shall have k into k plus 1 plus a 2 into k plus 1. Okay? When we look again, it is clear that this guy has the common bracket. And according to algebra, when we see this happening, we take out, we pull out, we factorize that common bracket. And this will give us a k plus 1. Okay? Here we shall be left with a k, and here we shall be left with this 2, everything divided by a 2. And this is clear that the left hand side is equal to the right hand side of the equation. Now, since the formula is valid for n is equal to k plus 1, okay, what does that mean? We are going to say the formula is valid for all positive integral values of n. Okay, so thank you for watching. Don't forget to subscribe, like and share the video for more about learning. Let's meet in the next video.